For this question, it says classify the given function as a polynomial function, rational. I got cut off a little bit there, but the rest of it says radical or root function, and then find the domain in interval notation. Our function is h of t equals 3 minus 9t over 4t squared. So let's start with classifying it. So I've already put up here what type it is. This is a rational function. And rational functions are of the form p of x over q of x. And really what we're talking about are functions that have variables in the denominator. When we have a variable in the denominator, we can identify that as a rational function. So once we've classified that as a rational function, then we want to find the domain in interval notation. So this last part over here is how we find the domain. So let's read over it. Since rational functions are in the form of a fraction, there's a restriction that the denominator cannot be 0. Okay, now what that means is that a 0 in the denominator is something that's undefined. Division by 0 is undefined and therefore not allowed. So you can find the restricted values by creating an equation, and the equation is the denominator equal to 0. So I've got q of x equal to 0 because we said over here that q of x is the denominator. So the solutions to this equation are the restricted values and must be excluded from the domain. So in the example that we have here, the denominator is 4t squared. That's our q of x. So we're going to create an equation, 4t squared, set that equal to 0, and solve this equation. I'm going to solve using the square root method. We would divide both sides by 4. That leaves me with t squared equals 0. We're then going to get rid of the square by square rooting both sides. And the square and the square root cancel each other out. But whenever we square root a square, that gives me a plus and minus symbol on the other side. And then we want to simplify. Square root of 0, which is 0. And because we have a plus and minus on 0, 0 doesn't have a sign, it's a neutral number. So we're going to get rid of that plus or minus symbol and just write 0. So this 0 is our restricted value. So what that means is that it's a restricted value, it's going to cause the function to be undefined. So let me show you what I mean. If I were to substitute a 0 into this function, we would have 3 minus 9 times 0 over 4 times 0 squared. And when we simplify, we would have 3 minus 0, because 9 times 0 is 0. 4 times 0, because 0 squared is 0. 3 minus 0 is 3. And 4 times 0 is 0. And we have what is restricted, what is not allowed. Division by 0 is something that is undefined. So because 0 causes the function to be undefined, 0 is not in the domain of this function. So I like to draw the domain on a number line. So we start off with the whole number line from negative infinity to infinity, all real numbers. But through our exploration, we found that we have this restricted value. So we're going to mark 0. And I'm going to mark 0 with an open circle because I'm going to exclude this value from the domain. And then all other values on the number line are part of the domain. We only had that one restricted value. So then I'm going to use interval notation to write down each one of these intervals. And I want to find the lower bound and the upper bound for that first interval, and the lower bound and the upper bound for the other interval. So for the first one, the lower bound would be negative infinity, and the upper bound would be 0. And for the other one, 0 is the lower bound, and infinity is the upper bound. And we're going to union those two sets together. So we found that the domain of this rational function is negative infinity to 0, union with 0 to infinity. I just want to point one more thing out to you guys. If you notice that I use parentheses, parentheses indicate that that value is not included in the set. So the parentheses here next to 0 indicate that 0 is not part of the set and not part of the domain. And then we also have these parentheses next to infinity. And infinity is not a number. It's a concept or an idea that the numbers go on forever. And so we're never going to use brackets next to the infinity symbol. For this question, we want to find the slope of the line containing the pair of the points. We have a formula, the slope formula, for finding the slope between 2 points. And that formula is m equals y2 minus y1 over x2 minus x1. Now, m is the name of the variable that we give for slope. And these other variables, y2, y1, x2, x1, these are the points. So we say we have 1 point, x1, y1, this point is on the line, and a second point, x2, y2, is on the line. So using 2 points on the line, we can calculate the slope of the line. So I'm given 2 points here, the ordered pair 2, 5, and the ordered pair 3, 8. And I'm going to let one of them be x1, y1, and the other one x2, y2. And it doesn't matter which one is which, as long as the ones are in the same ordered pair and the twos are in the same ordered pair. So then we're going to use the formula to do the calculation. So we want to start by doing y2. y2 is 8 minus y1. y1 is 5. Maybe I should use different colors. Let's try it with different colors. So y2 was 8. y1 is 5. And there was a minus in the formula, so I've used minus. And then we have x2. x2 is 3 minus x1. x1 is 2. So I've substituted those values into the formula, and then we simplify. 8 minus 5 is 3. 3 minus 2 is 1. And then I'm going to reduce that fraction. 3 over 1 is 3. So we have the slope of the line containing these points to be 3. And just as an added little piece of information, remember that the slope, once you calculate it, tells us about the line. So when we have a positive slope, that's telling us that the line is increasing as we look from left to right. And that means that we go up 3 for every 1 that we go over. So that's the meaning of that slope. It tells us the steepness of the line. In this question, we want to find x-intercepts and y-intercepts of the function. I like to start with y-intercepts because they're always a little bit easier. And when you're finding a y-intercept is where the graph either crosses or touches the y-axis. And because it's on the y-axis, that means that the x-coordinate will be 0. So the way that we find y-intercepts is by letting x be 0. So I want to substitute a 0 into the function, and that's going to give me, 0 cubed minus 0 squared minus 7 times 0 plus 7 over 0 squared plus 10. So I substitute a 0 in for x, and I'm going to simplify. And 0 cubed is 0, 0 squared is 0, 7 times 0 is 0, and 0 squared is 0. So we end up having 7 over 10 when we add all those up. So we have a y-intercept of 0 and 7/10. So then I want to find the x-intercept. Like I said, this is usually a little bit harder. An x-intercept is where the graph either crosses or touches the x-axis. And because it crosses or touches the x-axis, the y-coordinate will be 0. Our equation here is written in function notation, and it is f of x equals x cubed minus x squared minus 7x plus 7 over x squared plus 10. And because it's in function notation, this f of x is representing y. So we're going to be setting f of x equals 0. And that would give us the equation 0 equals x cubed minus x squared minus 7x plus 7 over x squared plus 10. And we want to solve this equation. When we first look at it, it looks pretty messy because of the fraction. There's a method for getting rid of the fractions called clearing fractions. And what we do is we multiply by the denominator on the left and the right of the equation. Whatever you do to one side, you have to also do to the other. And that is going to cancel out the denominator on one side. And on the other side, because we have a 0, 0 times x squared plus 10 is 0. So the fraction goes away, and we have 0 equals x cubed minus x squared minus 7x plus 7. And we have this polynomial equation that we're going to solve. So the technique that I'm going to use to solve this equation is called grouping. I'm going to use factoring and grouping. So I'm going to group these two terms together and group these two terms together. And we're going to factor out the greatest common factor from each group. The greatest common factor of x cubed minus x squared is x squared. If I factor that out, I'm left with x minus 1. And for the other group, I want to factor out the greatest common factor. We've got negative 7x plus 7. They have a common factor of 7. And I also want to include this negative sign. I want to carry that down, make this a minus 7 for what we factor out. If I factor out that -7, I'm going to be left with x minus 1. And if this grouping method is going to work properly, you need what's in these parentheses to match each other. And if they match each other, you can now consider that to be the greatest common factor of this term and this term. You now have two terms, and they have this common x minus 1. I'm going to factor that common factor out, and what's left is this coefficient and this coefficient. So we have x squared minus 7. So now I have it factored. It's 0 equals x minus 1 times x squared minus 7. And you set each factor equal to 0. And on this factor, x minus 1 equals 0, we would add 1 to both sides and get x equals 1. In this other one, we have x squared minus 7. I would add 7 to both sides. That gives me x squared equals 7. And I'll continue solving by square rooting both sides. And when you square root a square, they cancel each other out and you get plus and minus on the other side. And so we have positive square root of 7 and negative square root of 7. So we have x equals 1 square root of 7, negative square root of 7 as our x-intercepts. If we write those in as ordered pairs, that would be 1 comma 0, square root of 7 comma 0, and negative square root of 7 comma 0. Those are our x-intercepts. Thank you for checking out my videos. Have a great day.